Look up at the night sky. What do you see? You might see the moon, a few planets, and, well, countless stars. Each star is a distant sun, many with their own planets. All of these stars are part of our galaxy, the Milky Way. And our galaxy is just one of billions of galaxies in the observable universe. It is a vast, beautiful, and sometimes bewildering place. We have spent centuries trying to understand it. We have sent probes to distant worlds and built giant telescopes to peer back in time. We have learned so much about where it all came from and how it all works. But there is one question that sits at the very edge of our knowledge. A question that challenges everything we think we know. What happened before all of this began? Think about it for a moment. Our universe, with all its galaxies, stars, and planets, exploded into existence about 13.8 billion years ago. We call this moment the Big Bang. It was the start of everything we can see and measure. It was the start of space. It was the start of time itself. But what came before that moment? Was there anything at all? Was there a before? This question is perhaps the most profound one we can ask. It pushes the boundaries of science and philosophy. Before we dive into the latest scientific theories, let's take a step back. The idea that our universe might be part of an endless cycle is not new. In fact, it's one of the most ancient ideas in human history. They saw the repeating pattern of day and night. They watched the seasons change, from the birth of spring to the death of winter, and back to spring again. They observed the cycles of life and death in every living thing. Let's journey back in time to ancient Greece and Rome. Here, a school of philosophy known as Stoicism became very influential. The Stoics believed in something called ekpyrosis, a Greek word for a giant conflagration. Now let's travel to another part of the ancient world, to India. In Hindu cosmology, time is not a straight line but a vast repeating circle. The cycles are nested within one another, like cosmic Russian dolls. The life of our universe is just a single day in the life of the creator god Brahma. The ancient idea of a cyclic universe is making a remarkable comeback. Modern physicists, armed with powerful new ideas, are looking at this old concept with fresh eyes. They're building mathematical models that describe a cosmos which does not just expand but might one day contract and be reborn. Another fascinating idea for what came before the Big Bang comes from a field called loop quantum gravity. It suggests that the fabric of space-time is not smooth and continuous like a rubber sheet. Instead, it's made of tiny, discrete chunks or loops. Instead of crushing down to a singularity, the universe reaches a point of maximum density and then bounces. This is the Big Bounce. Perhaps the most mind-stretching idea of all is that our Big Bang was not the only one. Our universe might just be one small part of a much larger reality, a multiverse. The theory of eternal inflation suggests that this expansion process is not something that happened just once. It's happening all the time, forever. When a region stops its rapid expansion, it behaves like a bubble forming in boiling water. This bubble becomes a new universe with its own Big Bang. So we have these incredible, mind-bending ideas, but are they just beautiful stories? This is where science gets really clever. Physicists are not content with just having an idea. They want to find evidence. The answer might be hidden in the sky, in the oldest light in the universe. This ancient light is the cosmic microwave background, or CMB. If you look very closely with incredibly sensitive instruments, you find tiny little ripples, tiny variations in temperature from one spot in the sky to another. Scientists are meticulously scanning maps of the CMB, looking for these specific, non-random patterns. It's kind of like being a cosmic archaeologist. Scientists are developing new technologies to search for even more direct evidence. They are building new kinds of telescopes. Not telescopes that just look at light, but ones that can detect those faint ripples in the fabric of space-time itself, known as gravitational waves. LISA would be a giant gravitational wave observatory in space, made of 3 satellites flying in a triangular formation millions of kilometers apart. Detecting a primordial gravitational wave background would be like finding a fossil from the first instant of creation. How do scientists even come up with these incredible ideas in the first place? These theories are born from the most powerful and precise language we have for describing the universe, mathematics. Think about Einstein's theory of general relativity. It is not just a set of concepts, it is a set of beautiful, complex equations. When you solve these equations for an expanding universe and run the clock backwards, the mathematics leads you directly to the singularity. Loop quantum gravity is built on a new kind of mathematics. It describes space not as a smooth background, but as a network of mathematical connections, a spin network. Likewise, string theory proposes that all particles are just different vibrations of tiny, one-dimensional strings. Mathematics is their telescope for seeing worlds that are otherwise completely invisible. We stand at a remarkable moment in the history of human thought. We have journeyed from the edge of the observable universe to the very beginning of time, and even peered into the speculative abyss of what might have come before. We have explored a stunning variety of ideas, from the starkly simple concept of a universe born from nothing to the poetic grandeur of endlessly repeating cosmic cycles. We are explorers. We are questioners. It is written into our DNA to look up at the sky and wonder about our origins. This journey to understand our cosmic origins connects us to every culture and every generation that has come before us. By seeking answers to these ultimate questions, we are continuing a conversation that began thousands of years ago. The fact that we do not have a single definitive answer is not a failure of science. On the contrary, it is a sign of a vibrant and healthy field of inquiry. It is in this fertile ground of uncertainty and debate that the next great scientific revolution is likely to be born. We are like children standing at the shore of a vast cosmic ocean, having just begun to map its currents and tides, with the true extent of its depths still a profound and tantalizing mystery waiting to be discovered. The quest continues, and that perhaps is the most important thing of all.